Hi guys, this video talks about relations versus functions, function notation, and evaluation. Let's start with what is a function. A function is a defined rule or formula that assigns one and only one input, usually f of x, for each input, usually x. It's like a machine that makes an input x to produce an output f of x. So if we have a machine here, functions are machines where we can take x in to produce f of x. We remember from the past equations. So what is the difference between functions and equations in two variables if we're talking about x and y? The difference is in the notation. It's how we write a function. An equation is written with two variables, usually x and y. A function and functions are written with an input and an output. The input usually x and the output is f of x. So let's take a look at an example here. We have y equals 2x minus 4. This is an equation with two variables, x and y, while if we write it as f of x equals 2x minus 4, where we switch y with f of x, this is a function. So basically the difference is how we write the output, f of x. For equations, it's y. For functions, it's f of x. A second difference between functions and equations in two variables is in the solutions and output. An equation can have more than one solution or more than one value for y. In functions, we don't have two or more outputs for the same input. Every single x, which is the input, has one and only one output. If a defined rule has more than one output for an input, it's not called a function, but it's called a relation. All functions are relations, but not all relations are functions. What is a relation? A relation is a set of ordered pairs that can be represented in many ways. One of the ways is a relation set. This is an example of a relation set where we have four ordered pairs. The inputs in this relation are 2, 3, 2 again, and -1, which is basically the x coordinates of these ordered pairs. Now, the outputs are -2, -4, -3, and 1, which is basically the y coordinates of the ordered pairs. This relation is not a function because 2 here has two outputs. 2 has a -2 as an output, and 2 has a -3 as an output. And for a relation to be a function, each input should have one and only one output. The second way of representing a relation is by a map diagram, which is basically two circles. One of them represents the inputs, the other one represents the outputs, and the arrows to represent the relation between these inputs and outputs are going from one to the other. So in this circle, the left circle represents the inputs that includes 8, 9, 10, and 13, and the right circle represents the outputs, which are -1, -3, and 5. And I know that the left circle represents the inputs because the arrows are going from the left to the right. Now, if we look at the arrows going from the left to the right, 8 goes to -1, or the output of -8 is -1. The output of 9 is -3. The output of 10 is -1. And the output of 13 is 5. Since each input has one and one output only, or one arrow is going from the left circle to the right circle, this relation represents the function. Another way of representing a relation is by a table. Let's take a look at this example where we have X values that represent the inputs. And in this case, we have -2, -1, 4, and 4 again. -2, -1, and 4. And the outputs are represented by Y. So we have -16, -8, 32, and 48. 4 outputs. Now, this relation is not a function because 4 here has 2 outputs. 4 has 32 as an output, and it has 48 as an output, which means that this relation is not a function. The fourth way of representing a relation is by a graph. And we know from the past units that each point on the graph is represented by a coordinate pair. So I'm going to choose these points on the graph to represent coordinate pairs that can be part of inputs and outputs. So let's take a look at the first point right here where we have an x coordinate of 4 and a y coordinate of 4. So the input is represented by the x, which is 4, and the output is represented by the y, which is 4. A second example here where we have 2 is on the x, or 2 is the input, and 2 is the output. Another point here where the input is -2 and the output is 2. Another point here where the input is -3 and the output is 3. So all the inputs are represented on the x-axis and all the outputs are represented on the y-axis.
Before we move on, guys, I want you to stop the video, finish the class at the first page of the class practice before you move on and watch the second half of the video. So far, we learned that relations can be represented by a relation set, map diagram, and tables, and graphs. We learned that we can look at relation sets, tables, and map diagram to find out if each input has one and only one output to represent a function. Now, we can also look at graphs and find out if they're functions or not by using what we call a vertical line test. A vertical line test is used on graphs to identify if the graph represents a function or not. Let's take a look at our first graph right here. We have a graph. We're trying to figure out if this is a graph of a function or not. We're going to use this line, which is a vertical line, to be able to find out if this a graph represents a function or not. And this is how. All you need to do is to imagine that this line is going through the graph. And if this line crosses the graph in two different places or more, two or more different places, just like what we have here, then this graph is not a function. Let's use another example where we have this graph now, and we're trying to find out if this graph represents a function or not. We're going to use again the vertical line right here, and we're going to imagine that vertical line going through the graph. And if you look here, you'll find out that as the vertical line moves, it crosses the graph in just one spot only. That means that each input on this graph has one and only one output. That's why this graph represents a function. Now, I want you to stop the video again, finish the second page of your classwork before you move on with the video. Now we're going to learn how to evaluate a function. We talked about functions, what they are, how we can represent them, how we can identify them. Now we're going to learn how to evaluate them. This is an example. We have example 1, f of x equals negative 2x plus 3. The question is to find f of negative 3. When I say f of negative 3, I mean that I need to find the output for an input of negative 3. And to find f of negative 3, all I need to do is to switch x with negative 3, because negative 3 is the input, x is the input. By substituting x with a value, it will help me find an output for that input, which is in this case 9. Let's take another example. We need to find f of 2. So again, I'm trying to find the output of an input of 2. That means, again, I'm going to substitute x in the function, or the function rule, with 2 to try and find out an output in this case, which is basically negative 1. Negative 2 times 2 is negative 4, plus 3 is a negative 1. So on both of these examples, the input is negative 3, the output is 9, the input is 2, and the output is negative 1. Example number 3. Now you are trying to find 3 f of negative 3 plus f of 2. This means that you're trying to find 3 times the output of negative 3 plus the output of 2. And to do that, all I need to do is to substitute f of negative 3 with the output of negative 3, which we got before in example 1, which is 9, and to switch f of 2 with the output of 2, which is in this case the answer we got in example 2, which is negative 1. Now 3 times 9 plus negative 1 is just 26.